Welcome to Andy's Azure Architecture Talk. As a cloud architect, we are always thinking about improving the security of our solution. Today, I will cover a very well-known Azure architecture pattern that allows us to host our solution privately inside the network. Our solution will include Platform as a Service component, Azure App Service Web App, and Azure SQL database. Another very key Azure service called Privatelink. Privatelink simplifies the network architecture, particularly with Platform as a Service company. It eliminates any kind of data exposure to public internet by making them completely private inside a virtual network. Okay, let's get started. Technology topics are generally boring unless we map them to a real world story and look at the bigger picture. So let's look at our requirements of a fictitious university called Contoso University. In our story, Mr. John Smith is the principal of the university. He wants to build a website for his administration office. Admin office staff needs to manage students, departments, instructors, courses. The website definitely needs a backend database to store these information. Since the website will deal with students' personally identifiable data, the data must be very secure. In the future, university also has a plan to integrate their on-premise network with the Azure hosted network. Another very important requirement for this one is we have to keep the cost very low. Need to use Azure Platform as a Service component to keep the cost. Let's choose Azure SQL database for storing the data. Azure SQL database comes with its own firewall. Web app to host the web application. It can't access the Azure SQL database since it is blocked by Azure Database Firewall. In Azure Portal, you need to go to the firewalls and the virtual network blade of the Azure SQL database and turn on allow Azure services sources to access the server. Now the web app can connect to the Principal John looks at the implementation, not worried about the fact that database is now open to all the Azure services, not just our web app. He instructed the architect to do something so that only web app should have access to the database. Since the Azure App Service web app does not give a static IP address, we need to look for some other approach. Virtual network and Azure Privatelink come into rescue. Let's redesign. Create a virtual network so that external world should not have any access to the components inside the network. Then we create the subnets, web subnet, user subnet, and database subnet. We create the user subnet and a VM inside it. User VM is just for the testing purpose. We won't be dealing with real on-premise network here. Instead, this Azure VM allows us to test the web app on behalf of an on-premise admin user. We will also actually establish a site-to-site VPN from on-premise network in the future so that only people from the Contoso University network can access. Now let's bring the database inside the network. There are three different ways to integrate SQL database with a virtual network. The first one is using Azure SQL Managed Instance, or SQL Server on an Azure VM inside the network. Hey, but our university is looking for Azure SQL Database, platform as a service company, due to its cost advantage and low maintenance. Let's look at the other option. The next option is use VNet Service Endpoint. Service Endpoint with Azure SQL Database allows us to isolate the connectivity from a subnet or set of subnets to Azure service. In this case, Azure SQL. The traffic from the subnet to Azure SQL Database will always stay within the Azure backbone network. Let's see what we need to do if an user needs to access the database from on-premise. Service Endpoint does not work through VPN gateway. Only alternative is to open up the database firewall for an on-premise IP address. The communication will have to travel over public internet. CEO did not approve due to the security risk. The next option is Privatelink. Privatelink assumes a private IP address within a subnet. It allows connecting to the database using the private IP address from on-premise. Logically, the Azure service with Privatelink operates as if it is hosted inside the subnet. It abides by all the network traffic rules as defined by the network security group. Now let's enable Privatelink for Azure Web App. We also have a VM, the network, for testing purpose. When Privatelink is enabled for Azure Web App, it is accessible inside the network. Users from the VM can connect to the web app from a web browser. Users can also open a SQL Management Studio to connect to the Azure SQL database. Can the web app connect to the SQL database? No. Privatelink allows inbound traffic from the network, but the actual service can make outbound call to another network resource. Reiterating a very important point, a privately linked makes itself available to the other resources inside the network. But the service itself cannot make outbound call to the other resource. That's why to allow web app to connect to the database, we need to establish app service network integration via the delegated subnet. After we do that, now the users can browse the web app, connect to SQL database from on-premise. All the traffic stay private in the network. After we do that, now the users can browse the web app, connect to SQL database from on-premise. All the traffic stay private in the network. Let's review how exactly Privatelink works. In our design, web app connects to a database with Privatelink. In the app settings of the web app, database connection string is configured. Connection string has the database's fully qualified domain name, FQDN, mydb.database.windows.net. The question is, how this FQDN gets translated to a private IP address. When database Privatelink gets created in Azure, it also creates a CNAME entry in Azure DNS. If database FQDN is mydb.database.windows.net, the CNAME record points to mydb.privatelink.database.windows.net. A private DNS zone or a custom DNS server is needed for the name resolution to work for private links inside the network. The DNS entry resolves mydb.privatelink.database.windows.net to the private IP address. Let's look at the flow in the runtime. When web app tries to reach mydb.database.windows.net, it first gets redirected to mydb.privatelink.database.windows.net by the Azure recursive DNS. Then local DNS server or Azure private DNS zone resolves mydb.privatelink.database.windows.net to the private IP address. This is how private link works. Thanks for watching my video.